Let's explore the Routing Information Protocol, commonly known as RIP. In this video, we'll cover its configuration, implementation, and limitations. First, let's get a protocol overview. RIP is a distance vector routing protocol, which means that routers exchange routing information with their neighbors, including the distance to various networks. RIP uses hop count as its metric to determine the best path. The maximum hop count is 15. A hop count of 16 is considered unreachable. There are primarily three variants of RIP: RIP version 1, RIP version 2, and RIP next generation. RIP uses the Bellman-Ford algorithm for calculating paths. Now let's discuss the key characteristics of the RIP protocol. The administrative distance for RIP is 120. Administrative distance is a number that represents the reliability of a routing protocol. A lower number means that the routing protocol is more reliable. RIP sends out updates every 30 seconds. The time it takes for RIP to converge is slow. Convergence time is the time it takes for all routers to have consistent routing tables after a change in the network. RIP version 1 is a classful routing protocol. This means that when sending out routing updates, it does not include subnet mask information. RIP version 2, however, supports variable length subnet masking and classless interdomain routing. RIP also uses split horizon with poison reverse. This mechanism prevents routing loops by advertising a route back to the router from which it was learned, but with a metric of 16, indicating it is unreachable. Now let's compare RIP version 1 and RIP version 2. RIP version 1 does not send subnet mask information in its updates, while RIP version 2 includes it. RIP version 1 sends updates via broadcast, whereas RIP version 2 uses multicast to the address 224.0.0.9. RIP version 1 does not support authentication, whereas RIP version 2 does. Because of this, RIP version 1 does not support VLSM or CIDR, while RIP version 2 does. Now let's delve into the basic configuration of RIP. First, enter the router configuration mode. Then, enable the RIP routing protocol. You can specify the RIP version, but this is optional. Next, configure the networks to be advertised. If using RIP version 2, disable auto-summarization. Finally, verify your configuration. Here is an example of a basic RIP version 2 configuration. From the router prompt, type enable. Then, type configure terminal to enter global configuration mode. Type router RIP to enable the RIP routing protocol. Then type version 2 to specify that you are using version 2 of RIP. Next, specify the networks to advertise using the network command followed by the network address. Use the no auto summary command to disable automatic summarization. Then, type exit twice to return to the router prompt. Finally, type show IP protocols to verify the configuration. Now let's explore some advanced features of RIP. These include authentication, passive interface configuration, default route advertisement, and route filtering. We can secure routing updates with Message Digest 5 or MD5 authentication. Configuring a passive interface prevents sending updates on specific interfaces. We can advertise a default route to other routers, and we can control route advertisement with distribute lists. Here are some configuration examples. To configure MD5 authentication, first create a keychain with a key and a key string. Then, on the interface, enable RIP authentication mode MD5 and specify the keychain. To configure a passive interface and default route advertisement, enter router configuration mode, then specify the passive interface and use the default information originate command. Now let's review some key verification commands for RIP. The show IP protocols command displays routing protocol parameters and status. The show IP route RIP command shows only the RIP routes in the routing table. The show IP RIP database command displays all RIP routes learned by the router. The debug IP RIP command shows real-time RIP update information. The Show Running Config command displays the current RIP configuration. Here is some sample output from the Show IP Route RIP and Show IP Protocols commands. Now let's discuss the limitations of the RIP protocol. The maximum hop count of 15, where 16 equals unreachable, restricts the size of networks that can use RIP. RIP has a slow convergence time due to its timers. Because RIP sends out full table updates, this results in high bandwidth usage. RIP version 1 does not support route tagging. Route tagging is the ability to add tags to routes, and this feature is useful for filtering routes. RIP does not support unequal cost load balancing. Because of the hop count limitation, RIP is unsuitable for large networks. Here is an illustration of the hop count limitation. If a route is more than 15 hops away, it is considered unreachable. Now let's explore some troubleshooting techniques for RIP. Common issues include routes not being advertised, authentication failures, version mismatch, and split horizon issues. To troubleshoot routes not being advertised, check the network statements and verify that the interfaces are active. To troubleshoot authentication failures, verify that the key chains and authentication settings match on both sides. To troubleshoot version mismatch, ensure consistent RIP versions across all routers in the network. If there are split horizon issues, consider disabling split horizon on non-broadcast multi-access or NBMA networks. Here are some useful debugging commands. Use the debug IP RIP command to enable RIP debugging. This will show real-time RIP update information. Use the no debug IP RIP command to disable RIP debugging. Also, the undebug all command can be used to turn off all debugging. The Show IP Protocols command is useful for checking RIP timers and processes. Let's go over some best practices for RIP. Always use RIP version 2 instead of RIP version 1 when possible. Implement authentication to prevent unauthorized updates. Use passive interfaces to reduce unnecessary updates. Disable auto-summarization for more precise routing. Consider route filtering to control network visibility. Plan the network topology to avoid exceeding the 15-hop limit. Here is a summary of RIP. RIP is a distance vector protocol that uses hop count as its metric. The maximum 15-hop limit makes it suitable only for small networks. RIP version 2 adds variable length subnet masking, classless interdomain routing, and authentication support. The convergence is slow compared to modern routing protocols. On the other hand, RIP is simple to configure and troubleshoot. Because of its limitations, when should we use RIP? RIP is suitable for small networks, simple topologies, legacy environments, and learning environments. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.